Given that g of x is equal to this function, we got 6x squared plus x minus 1 all over 4x squared minus 4x minus 3. We want to find the following limits. The limit as x approaches negative 1/2 from the left, the limit as x approaches negative 1/2 from the right, and the limit as x approaches infinity. All right, so now we do see there's a rational function. We have a quadratic term in the numerator, quadratic term in the denominator, right? First thing we probably want to do is just factor this guy out, okay? So in the numerator, we get 3x minus 1. Looks like we get 2x plus 1 here. And on the denominator, we get 2x here, and then we get a minus 3 and a plus 1. So actually, right, so you're probably thinking, oh yeah, because of negative 1/2, right? The negative 1/2 is going to be a vertical asymptote, but actually these do cancel out. So it's actually going to be a hole, right? We're removing this point from the function. So this function is actually just equal to 3x minus 1 over 2x minus 3. So actually, where is the vertical asymptote here? Right, the vertical asymptote here is at 3/2, not at negative 1/2. Okay, so you got to be a little bit careful with this one. Well, let's take a look, right? What is happening as x approaches negative 1/2 of this function? And hopefully you realize at this point, it actually doesn't matter if you're coming from the left or from the right. Okay, both answers here are actually going to be the same because, well, we're just going to go ahead and plug the negative 1/2 in here. Okay, so we get 3 times negative 1/2 minus 1. We get 2 times negative 1/2 minus 3 here. Notice we do not get a 0 in the denominator, right? So that's good. Okay, so we get what? Negative 3/2 minus 1, which is negative 5 over 2. And on the denominator, we get negative 1 minus 3, which is negative 4. Okay, so we get negative 5 over 2 divided by negative 4, but we never divide by fractions, right? We always multiply by the reciprocal. So in this case, we get a final answer of 5 over 8. That's this limit. The limit as x approaches negative 1/2 does not matter if we're coming from the left or from the right. The answer is just going to equal 5/8, which is a point on the graph, right? Remember, it's going to be a hole, right? This is called a removable discontinuity here. Okay, what about the limit as x approaches infinity here? Right, the limit as x approaches infinity. Now, if you look at the original function, right, we got the 6x squared plus x minus 1 divided by 4x squared minus 4x minus 3, right? We want to look at the denominator. The highest term here is that x squared. So we're going to divide everything by x squared. Okay, so 6x squared over x squared. We got x over x squared and minus 1 over x squared on the numerator. And on the denominator, same thing. We're going to divide each term by x squared. Okay. Now what cancels out here? Right, well, the x squareds cancel out, right? So we're just left with 6. Right here, one of the x's cancels out, so we get 1 over x squared. I'm sorry, that's 1 over x. Okay. And then here we get 1 over x squared. And for the bottom one here, the x squareds cancel out, we get 4. Here, one of the x's cancel out, we get 4 over x. And of course, that just stays 3 over x squared. Of course, we're still finding the limit, right? And you don't have to write it every single time, I guess. Now let's go ahead and plug the infinity into all of these x's. And the good thing about each of these, right, check these out. When you plug the infinity in here, that just goes to 0, right? That goes to 0, this goes to 0, that goes to 0, right? So really, what do we left with here? Right? Just 6 over 4, which is 3 over 2. So that is the answer for this limit, right? Remember, whenever we find the limit as x goes to infinity, that's going to be a horizontal asymptote.